Welcome to Sequences. Today we are going to focus on arithmetic sequences. I know the word looks like arithmetic, but when you're using it to describe sequences as like the adjective, it's arithmetic sequences. So you ask, what is that? Well, an arithmetic sequence is a pattern of numbers where the difference between any two consecutive terms is a constant value. So right here, I gave an example where you can easily see that I'm adding the same value each time. It's not always as easy as this one to maybe find what that common difference or what value that is that you're adding. So we're going to look at how to go through, look at these sequences, maybe come up with formulas to try to figure out, terms down the line. So let's look at this one again because I do want you to notice something. And that is, hey, if you're adding the same number each time, where have we seen that before? Well, we've kind of seen it with lines. Yeah, like linear functions, right? So we call this a sub 1 because it's our first term, and this is a sub 2, a sub 3, a sub 4. And so if we are looking at this as being like a pattern, we can see that the slope would go up 4 here, up 1 here. Oh, well, look at that. It's like going up 4, up 1, up 4, up 1. So our slope of this line would be 4. Okay, great. So can I write an equation since I have a point? Actually, I have several points, and I have a slope. Can I write an equation? So do you remember back in the day when you worked on some point slope and y minus y1 equals the slope and then x minus x1? Okay, that's great. I'm just going to change the variables on you a little. When we work with sequences, we say that this is like n and this is our a sub n term, right? So if n is 1, in other words, our first term, then a sub 1 is 7. So you can see that that's kind of what this means, right? So instead of using y and x, we're going to use a sub n minus we can use our first term if we want to. And instead of using the slope, we call this the common difference. And we use a d for it. And then here we would have n minus 1. Now this is using point slope if I were to use this first point right here. So let's do it. So a sub n minus 7, because that's the y value, equals 4 is our slope, and then n minus 1 because it's the first value. So a lot of times they'll need to have a sub n by itself. They like to have that by itself. So I just move the 7 over. So if you add 7 to both sides, you get this nice formula right here. Now, it's not the only formula that works. I just happen to use the first point. What if I'm not given the first point? Can I just use the third point or the fourth point or the second point, whatever you want, right? So to give you an example, I could do a sub n minus, why don't we use the second term? And I'm still going to use d, but in this case, I would do n minus 2 because it's the second term. So I can do a sub n minus 11 because that's my second term. And the slope would be the 4 and then n minus 2. Great. And so if I wanted to, again, I could get a sub n by itself by moving the 11 over. And I have this lovely formula. Now, you agree that if I plug in any value of n, I should get the same answer for my a sub n. So you can test that, like choose a number like 10 for n, right? If I plug in 10 here, 10 minus 1 is 9, 36, 36 plus 7, you're looking at 43. Excellent. If I plug in 10 here, 10 minus 2 is 8, and I have 32 plus 11. Oh, 43. Great. So these equations are the same equations because, again, it's just like point slope. Now here, of course, is your official explicit formula. We call this the explicit formula, which means that I can find the nth term. So I can find the 99th term or the 52nd term by just plugging that value in for n. Now, the one that you'll probably find when you Google things is this one right here, because lots of times they want you to have the first term and they use the n minus 1. But like I showed you before, you could use any term you wanted. Say you had the fifth term. Well, it's fine if you want to use the fifth term as long as you use n minus 5, because again, you're using the point 5 comma a sub 5 as your point on this made up line, right? It's a linear pattern. It's not a line per se because the dots do not connect. Because I can't have, n be 1.5, right? So n can only be the whole numbers. And so I don't have a linear function per se, but I do have all the dots of this linear function. Just the whole numbers, right? Where n is the whole numbers. So let's look at another pattern here. Well, another arithmetic. I'm telling you right now it's arithmetic. But again, do not let the fractions scare you. So a great strategy here is just to find a common denominator. So right here, if I can see, okay, well, let's use a 6. So these already have a 6 here. And a way to rewrite 2 as sixths is 12 sixths, right? Because 12 divided by 6 is 2. And then here, if I multiply the top and the bottom, I get 2 sixths, right? So now it's easier to see that like, oh, the numerator is going up by 5. Yeah, okay. So right here, I can always check though, just by saying, hey, if I take the second term minus the first term, and the third term minus the second, shouldn't they be the same, right? If I'm checking for arithmetic. So I can always check this by saying, okay, 2 minus 7 sixths. So again, you would always find a common denominator anyway. And you get that both of them would be a difference of 5 sixths. So that is our common difference slash, remember if you're thinking about it, that's kind of your slope. So depending on what point you want to use, if we want to use a sub 1, since we're given a sub 1, we can totally do that. So we have a sub n equals 1/3 plus our common difference is 5 sixths, and we have n minus 1. Great. You know what though? I really like the number 2, so I'm going to use the third term. Is that okay? Sure. I can use the third term as long as I then put n minus 3. So again, these are equivalent equations here. They are going to give us the same value of a sub n if I put in any different n value. In other words, if I go through and simplify and put this into like a y equals mx plus b format, they would have that same b value. Let's go ahead now and see. I am given different pieces of information. Here, I am given the fourth term and I am given the common difference. Well, just like with a line, if you're given the slope and a point, I want you to look at it like that. If you're given the slope and a point, you can find the equation. Again, we're kind of treating this as 4 comma 17 because it's our nth term, our fourth term, and a sub n is 17. So if I have a sub n, I can use my fourth term. I have my common difference of -6. So you know what? Instead of doing plus -6, I'm just going to write -6. You'll see it like that more commonly. And then I need n minus 4. So this is an explicit formula because explicit just means that if I plug in any value of n, I can find the nth term. And so now if I'm looking for my first term is, let's find it. Let's plug in a 1 for n. And I get 17 minus 6 times -3. And I get 17. Careful, it is plus an 18. And so a sub 1 is going to equal 35. Well, let's see here. Does that make sense that a sub 1 is bigger than a sub 4? Well, yeah, because aren't I going down 6 each time? So if I'm going down 6, that means to go backwards, I would have to go up 6. So if I were going down 6, that would be 11. But if I were going up 6, that would be 23, 29, and then 35. So could you always go through for something like this and just add 6 backwards? Sure. you can totally do that. But let's say now I wanted the, 22nd term. You don't want to sit there and subtract 6 22 times, right? That's ridiculous. So use your formula. All right, in this problem, it looks like we are given 2 terms as opposed to 1 term and the common difference. So here, it's almost like being given 2 different points. Now, I will say this, I should have put in here, find an explicit formula for the arithmetic sequence, because it is arithmetic, because that's the video that we're working on here. But if you're not given that, then technically this could also be a geometric sequence. It could, right? Because any 2 terms, you can make a geometric or an arithmetic, but this one is arithmetic. So I'm going to treat this as 2 points on a line. And so my 4th term is 13. My 16th term is 31. So let's find the slope. Notice that these go up, like your y values go up 18. And your quote-unquote x values go up by 12. So if I'm finding my slope or my common difference, I'm looking at 18 over 12. Who made up this problem? 3/2. Or if you want to use decimals, you can use 1.5. All right. So let's go ahead now and write an explicit formula. So a sub n equals, I love the number 13, so I'm going to use this 4th term here. So I'm going to use 13 plus my common difference is 3/2. And then remember, I need to use n minus 4 if I'm using this 4th term. Now, for some reason, if you have a teacher that really wants the n minus 1, then you can go back and use this formula and plug in 1 to find that first term. And so that's always going to work for you, right? So right here, though, I am asking for the 50th term. So let's go through and plug in 50. So the 50th term, everywhere I see an n, I'm going to put in 50. And so 3/2 times 50 minus 4. All right, 3/2 times 46. Excellent. And when I multiply that, I know that 23, and that's a 1. And so that, I believe, is 69 plus 13, which gives us 82. So my 50th term is 82. Ta-da! Now, like I said, you can always go back and find the first term if you want to rewrite this using the other explicit formula, the one that you see a lot using a sub 1 and n minus 1. All right, so just to recap, again, an arithmetic sequence, they have linear patterns, right? So look for those linear patterns. You can use any term to find an explicit formula. You don't have to use the first term. You can use any term that you're given. You just need to make sure that you don't use n minus 1, but you use n minus whatever number term you are using. And then, of course, if you're given 2 terms, you want to treat it like you're given 2 points on a line so that you can go ahead and find that slope, really known as the common difference when we talk about sequences, but a slope if we're talking about linear patterns. All right, have fun.